So today we're going to talk about section 7.4, which is another integration technique called partial fractions. Sometimes you learn how to do the algebra of this stuff in a high school or a pre-algebra class, like some class or pre-calculus class. Some classes do that and some classes don't. So maybe you've seen it before, maybe you haven't. Like I never had seen it. So we're going to find something called the partial fraction decomposition for 1 over x squared minus 4x plus 3. And we're going to use it to find the antiderivative of 1 over that expression. So why can't we do a u substitution right now? What would need to be there? If you let u equal like the whole denominator, for example, yeah, there's no du on the top. Does that make sense? So partial fractions allows you to kind of take fractions that have been added together and uncombine them. So how you start is you factor the polynomial in the denominator. So how does x squared minus 4x plus 3 factor?
So that's x minus 2 squared minus 1.
Factor, not complete the square.
Oh.
How does it factor into x minus 3, x minus 4? Okay? Oh, x minus 3, x minus, I was just testing you. X minus what? 1. And for some reason that eraser thing is not available. Why? I don't understand. Eraser. Okay. X minus 1. Okay. So you have 1 over x minus 3 times x minus 1. So you can think you got that by adding together a fraction that was some number over x minus 3 plus some other number over x minus 1. And there's a mathematical theorem that guarantees this will work if the degree of the numerator is exactly 1 less than the denominator. So the degree of the denominator is 1, right? Constants have degree 0, no x's, okay? And you're going to figure out what those numbers are, all right? Yes?
Wouldn't the degree technically be 2 since you have 2 different x's?
The degree is 2 if it's x squared. The degree is 2 of the thing on the left, but not the thing. I'm talking about the things on the right. Okay? So that's your first step, is break it up into the 2 factors. And then we're going to figure out what those a's and b's are. And what you do is you take this expression and you multiply it by x minus 3 times x minus 1. And I'm usually not going to write that step down because there's a really obvious pattern to what happens when you do so. What happens when you multiply that x minus 3 times x minus 1 by the stuff on the left side of the equal sign? Over x minus 3 times x minus 1, which gives you 1. You don't agree with that? You got 1 on the left. How about on the right, when that stuff distributes to the a? A times quantity x minus 1. Do you guys agree with that? And then when it distributes to the next piece, you get... Yep. Okay. Now there are multiple ways to find a and b at this stage, but the easiest way that only works sometimes is to choose clever values for x and plug them in. This equation is true for any x's, so you can pick a specific x. And you pick an x that makes one term go away. So what number could I plug in for x here that would make that term disappear? 1. So plug in x equals 1. That implies you have 1 equals b times, what's that going to be, 1 minus 3, so negative 2, right? So 1 equals negative 2b, therefore b equals negative 1/2. Okay. So that got rid of the, plugging in 1 got rid of the thing that had the a. How would you get rid of the thing that had a b?
3.
Plug in 3. Then you'll have 1 equals, I believe, 2a. Do you guys agree with that? And so a is equal to 1/2. Okay, so most of that really is just algebra. Have any of you seen that before? Some of you? Okay, if you haven't, it's okay. It's not a problem. So what that tells us is that we can take this original integral And we can make it into the integral of a over x plus 3. So 1/2 over x plus, oh, gosh darn it, x minus 3 plus -1/2 over what? X minus 1. How could you check and see that you were right? Add them by finding a common denominator. Does that make sense? This sort of undoes that process. So you could multiply the first fraction by x minus 1 over x minus 1, the second one by x minus 3 over x minus 3, simplify the numerators, and you should get back what you had. Okay, it will work out. And now why is that helpful? Can you integrate both pieces on the left? Yep. You can. This is the same thing as, first of all, 1/2 times the integral 1 over x minus 3 dx minus 1/2 integral 1 over x minus 1 dx. And it's technically a u sub, but it's a really easy u sub, so there's no reason to really even do it. What's the antiderivative of 1 over x minus 3? Natural log, absolute value, x minus 3, minus 1/2 natural log, absolute value, x minus 1. And then don't forget your plus c on the end.
So once you do, like, say, on the kind of left-hand side where you have like x equals 1, so it's 1 equals the,
Yeah.
what happens to that 1 and that 3? Is it just kind of like an arbitrary thing that doesn't really matter anymore?
The equation that I have right here is true for any x's, so it's also true for specific x's.
Okay.
So it doesn't, I think you're like, maybe you're kind of weirded out by the fact that you can just pick an x and then not care about the rest of them. Is that the part that bothers you?
Yeah.
Yeah, it's okay.
Okay.
Because it's true for all x's, so it's also true for 1. And so that 1 is the one that lets you find that value.
And so you can find A and B with 2 different x values.
In this particular example, there's another way to do it as well, and this way will not work for some problems that we have. Okay, but for this kind of stuff, it will work.
Do those added constants just go into C?
Do those add? Nope. Because there's no, the stuff on the left is not integration at all, is it?
No.
No. So it's just saying that it's true for all x's, and then plugging those specific x's lets you find these values. You don't even need anything else. Okay, yeah, Zach?
So when you're doing the 1 over x minus 3 times x minus 1 equals a, so on, the order of which one is
Doesn't
okay,
matter.
it doesn't matter.
Nope, it doesn't matter. You will get the, so do you guys understand? The question is if you put, say, the x minus 1 denominator first and the x minus 3 denominator second, is that important? That's the question, okay? The answer is no. You're going to end up with, your a will then equal -1/2 and your b will equal 1/2, but the -1/2 is still over the x minus 1. Does that make sense? It ends up paired with the same denominator. Okay. Now I want to say one thing. Often, like things like Wolfram Alpha and ways to check your answer are going to do simplification that you might find confusing. Remember that there are properties about logs? So what are these coefficients actually? Exponents. So this is also the same thing as ln square root absolute value x minus 3 minus ln square root x minus 1 absolute value. Do you agree with that? And whatever you have 2 logs subtracted, what does it condense down to? A log of a ratio.
Absolute value of the ratio or not?
It is. So how I would say the best way to write it is log of big, huge square root, absolute value, x minus 3 over x minus 1. We are not going to make you do that, okay? Like the answer that I boxed is totally good enough. You can stop. It's not a problem. Just if you're doing problems like, say, for your take-home quiz and you want to check your answers, this might have been something that they did. Does that make sense? So just watch out for that. It's a
Wolfram Alpha will give you?
I haven't checked, but probably. Yes?
So the only way this works is because B and A, when added together, equal 0,
No, that's not always true. Let's do another example, okay? Like, let's do another one, because no, you see patterns that are that are there but are not generalizable. Okay. All right, so this guy. So the first case that we have is your denominator is a product of distinct linear factors. So what do those all those words mean? What does distinct mean? Different is a good way of saying that. Linear means like ax plus b, no squareds, okay? And factors means that there are members of that product, okay? So take that denominator and factor it. 2x cubed plus 3x squared minus 2x. What's the first thing that you can take out? The x, great. X times 2x squared plus 3x minus 2. Then that is 2x times something and x times something.
I think that's 2x minus 1 and x plus 2.
Let's see that. 2x minus 1, x plus 2. Do you guys agree with is that a good consensus? Okay.
Makes sense.
Makes sense? Great. Okay, so now proceeding with the partial fractions business, we have x squared plus 2x minus 1. I'm just going to write that denominator in its factored form. And you break it up with one ratio per factor, per unique factor. They're all different, right? You see that? So what's the first factor we have?
X.
X. Is x linear? Yeah, so that one's a over x. What's the next factor? 2x minus 1, so it'll be b over 2x minus 1. And the last one is c over x plus 2.
So before you get to this step, would it be a good idea to factor the numerator and see if anything cancels?
Yes, that would be a good idea, but I think it's pretty much never going to happen.
All right.
So, but yeah, if you had factors that canceled out, then you should do so, but I don't think that, I have not seen a problem yet for which that occurs.
Okay.
Okay, now what do we multiply by to make the denominators go away? X and 2x minus 1 and x plus 2. This step you could just do in your head, right? Because it's going to be, what's going to happen to the right-hand side every single time? It's going to go away, yeah. So you got x squared plus 2x minus 1 will equal a. So when that thing I have written pretty small distributes to the a over x, what's left? 2x minus 1 and x plus 2. Do you guys agree? Okay, how about to the b? Who's left when that thing distributes to the b? X and x plus 2. And then how about when it goes to the c? X and 2x minus 1. Okay. Is everyone all right with that part of it? Okay, now you've got to pick clever values to plug in. And in the first example we had, the thing on the left side was just the number, so the x we had didn't get plugged into that side because there was no x. But in this example, we have x's on the left side. So when you plug in that particular x, it goes into both places, both the left and the right. So what number could I plug in to make the b and c terms go away? 0. Okay, if I plug in 0, what is the left side going to be? -1. On the right, I'll have a times -1 times 2. Do you guys agree with that? Okay, so that means a is equal to 1/2. Right? Okay. -2. Divide -1 by -2, you get 1/2. Yeah?
It's not a division.
To get a by, if you have 2a equals something, to get a by itself, yes, you do divide. How would you make everything except for the b go away? Plug in x equals 1/2.
No, I was going back a step. I don't think 2x minus 1, plugging -1 simplifies to -1.
I didn't plug in -1, I plugged in 0. Yeah, sorry. Okay, so if x is a half, I can't do fractions fast, so what's a half squared? A quarter, that'll be +1, -1, do you guys agree with that? Okay, equals b times a half plus 2. So that's 1/4 equals b times, what's a half plus 2 as an improper fraction?
Therefore,
5
5 halves.
halves. So 1/2 times 5 halves says we've got a quarter equals b times 5 quarters. So what must b be? B must be, I think, a fifth. Do you guys agree? The 4's cancel, you divide the 5 over, you get b as a fifth. That was the hardest one because of fractions. What's the last number you can plug in to make everybody except for c go away? -2. Great. Okay, so that's 4. I'll move this up so you can see it. 4 minus 1 on the left side equals c times -2 times what I believe is -5. Is you agree with that? Okay, so that's -1 equals 10c. Therefore, c is -1/10. And the hardest thing for all these problems is getting those a's, b's, and c's. The resulting integrals often do not end up being very difficult. Does that also make sense? You're going to have lots of things that involve ln's, lots of denominators, right? Okay. Okay, so your original integral, so I believe I had a over x, it'd be 1/2 over x plus a fifth over, which one? 2x minus 1. And then plus -1/10 over x plus 2.
Should we simplify that?
I'll pull, I mean, as in, like you said, let's just pull the constants out sort of after anti-differentiating. Does that make sense?
Yeah.
Or pull them out and then anti-differentiate. So what's the antiderivative of that first thing? 1/2 ln absolute value of x. Yep. Okay, the next one, that 1/5 we'll pull out. We have an ln absolute value 2x minus 1. But because it was 2x minus 1, what do you have to compensate? A half? That's kind of the reverse chain rule, isn't it? And then how about the last thing? Will be minus 1/10 natural log absolute value x plus 2. So your final answer is 1/2 ln absolute value of x. Could you turn that off?
Yeah, I'm gonna.
Okay, thanks. Plus 1/10 ln absolute value 2x minus 1 minus 1/10 ln absolute value x plus 2 plus c. Is that all right? Wolfram alpha probably will make it into a radical expression. That one, Professor Faudry did put in the notes what it might look like, so you could take a look at that and make sure you understand just so you can check your answers, but I don't have time to go into it right now. Does that make sense? Okay. So this technique only works if the degree of the numerator is less than the degree of the denominator. So degree of numerator must be less than degree denominator. That's needed. And I mean strictly less than, not less than or equal to. Yes?
Okay, but here, can't you just do the, like, equation fraction division thing?
Yeah. Uh-huh. So what we're going to do is we're going to do the equation division thing called long division.
Oh, God.
Oh, God. Here it comes. It's back to bite you in the butt. Okay, so Here's how I helped myself. 9 divided by 2 translates into 2 going into 9 like this, right? I cannot do it unless I see a number first. I know that's right, yes? Okay, so the fraction that I have, if I write it in the long division way, which part goes under the check mark, so to speak? The 3x squared plus 6x plus 2. What are we dividing into it? Mm-hmm. Okay. And this,
There's this other method that kind of.
synthetic division doesn't work for stuff like this. Don't try to use it, it sucks.
Okay.
It only works for linear factors, leading coefficient 1. You're not going to have any examples of that in this class, and they shouldn't teach it to you in school. My opinion's been recorded, and it's going to go on YouTube. I hate that method. It's bad. Okay, moving on. Okay, now you think, what do you multiply that x squared by to make it match 3x squared? And it is just 3. So we have 3x squared plus 9x plus 6, multiplying 3 by everything on the left. And then you take it away. Much like if you're doing 2 into 9, you say, oh, that goes in there 4 times. 4 times 2 is 8, and then you subtract. It's the exact same process. This must be a...
You can get negative.
And this when you have x's in your answers. So, and now you subtract, you be a little bit careful with the negative sign. What happens with the 3x squareds?
Are you supposed to put the 3 on the right end of the division sign?
I just choose to line it up with the kind of number it is. So you know how in regular division you have like 10, you have hundreds, tens, and ones and stuff like that, right? And that's like your placeholders and where they're located. With polynomials, you have powers are your placeholders. So squareds, linears, and constants. And if you'll never go lower than constant. Does that make sense? It's kind of like an ordering system as well. So what happens to the 3x squareds? They go away. And then we get negative 3x minus 4. Why is those negative? Yeah, I do grammar real good. So that was on purpose, okay, in case that wasn't clear. So why is it negative? Because you do 6 minus 9, which is negative 3, right? 2 minus 6 is negative 4, okay? So that tells you that this is the same thing as 3 plus negative 3x minus 4 over x squared plus 3x plus 2. How could you check that answer? You could get a common denominator. Does that make sense?
Okay.
Multiply the thing on the left by denominator of thing on the right.
This goes back to the thing we're doing before.
Exactly. So the 3 you can integrate and it's just 3x, right? That's easy enough. But the second piece we have to do partial fractions on. Okay? So let's do partial fractions on that bit. So negative 3x minus 4 over, I think that factors into x plus 2, x plus 1. So you'll have a over x plus 2 plus b over x plus 1. What are we going to multiply by? Denominator of the left, which will give us negative 3x minus 4 equals a times x plus 1 plus b times x plus 2.
Would it ever be subtraction when those partial fractions?
You don't ever have to do subtraction because your a's and b's can be negative numbers. Does that make sense? Okay. Now what are we going to plug in to make the b go away? Negative 2. That will give us 6 minus 4 equals a times negative 1, I believe. So 2 equals negative a, and therefore a is equal to, great. And if x equals 1, negative 1, excuse me, you have 3 minus 4 equals b times what? Positive 1? Great. So negative 1 equals b. Do you
When it gets simple.
say that again?
I love it when it gets simple.
It gets simple, yep. So your integral is now the integral antiderivative of 3, Gesundheit, plus negative 2 over x plus 2, plus negative 1 over x plus 1. And you've made it into something that you can actually anti-differentiate, right? So what's the antiderivative of 3? 3x, great. Next we'll have minus 2 times, yep. Don't forget the absolute values, okay? Because if you do, you're going to lose points, as you may have on your quiz. Minus ln absolute value x plus 1 plus c. Yes?
So for like an actual of like x squared, x to the fourth, you don't really need the absolute value?
It depends on what your x squared, x to the fourth is with. If it's x squared minus 10, you do, because that goes negative sometimes. But if it's x squared...
just by itself?
Yes, yes.
Points off for
Yeah.
doing that?
No,
Or-
if it is the case that the quantity you have is positive and you drop the absolute value bars, in that case, there's no problem. Yep. Okay. Does that, you guys, does this question make sense, guys? Yes. Desmond?
Okay, now this probably matters, but can you separate the natural log of stuff added to stuff?
Nope, there's no rule for that.
Okay.
Nope. Good question, but, okay. So the next one, we have another case where there are something called repeated linear factors. And so first thing that happened on this slide is Beth forgot her integral sign, so it's on your paper, it's just not here. Okay, so notice how my denominator is factored for you, and x minus 2 is squared. That's what it's called, to be repeated, as it's repeated twice. So what you have to do in that case is have one product for every power up until your last one. Oh, no!
Yeah, that's not what the problem
Oh, shoot. So what I have is the integral of, I think I made it easier, x squared plus x plus 1 over x plus 2, it's even in front of me, times x plus 1 squared. Okay, great. I bet there's a reason I did that, and it's probably because it's easier. Okay. So, break that into, so you got x squared plus x plus 1 over x plus 2 x plus 1 squared. That's a over x plus 2. And then you have the x plus 1 squared. And how you handle that is you do b over x plus 1 and c over x plus 1 squared.
Is the factor in the numerator or greater than the denominator?
It's x plus 2.
Yeah, so it's not, because if you were to, the denominator, when you square it out, would end up having a leading term of x cubed.
Okay.
Does that make sense? Why? Because you've got a squared and another x. If you multiply that all together, you're going to get x cubed somehow. So long division not needed. That's what you were checking, right?
Yeah.
Yeah. Now, this will always happen when you have repeated factors. It's like, what if that was a cubed, like x plus 1 cubed? Then I'd have to have b over x, c over x plus 1 squared, and d over x plus 1 cubed, okay? And it's because, like, think to yourself, what's the common denominator of the stuff on the right? It is the thing on the left, right? Does that make sense? Like, if you found the common denominator of thing on right, it is the denominator of thing on left, yes? Could that middle term be 0? Is that possible? Would the common denominator of the first and last thing still be the thing on the left? Yeah, so it's possible you might find a value is 0, but this is how you account for those repeated factors. You need one term for up to every power. Okay. But after that, it's a little bit the same, except for our fancy, clever plug-in stuff is not going to work perfectly. We'll do something different, okay? So first thing, when you multiply by the denominator of the left side, you get x squared plus x plus 1 equals a times what? X plus 1 squared. And remember, we're multiplying by the denominator on both sides. B is getting multiplied by x plus 2 and any x, and an x plus 1. Very good. And the c will be multiplied by x plus 2. Okay, great. Okay, what's one clever number to plug in? -2, great. That will give us 4 minus 2 plus 1 equals a times -1 squared. So that's 3 equals a. Okay.
Sorry, did you explain why that c up there is c over x plus 1 squared?
Yeah, I think I did. You just it's a complicated mathematical theorem, but whenever you have repeated linear factors, you have to list every factor up to that counting by whole numbers. So like x plus 1 squared is x plus 1 times x plus 1, right?
Mm-hmm.
You have to account for the fact that it could have been something over x plus 1 and then something over x plus 1 squared. Had that been x plus 1 cubed, you would need a third term.
So if I just put c over x plus 1, I get the problem wrong?
Yes,
Okay.
definitely. Okay. What is the other clever number you can plug in? -1. So that gives us 1 minus 1 plus 1 equals c times 1, I think, right? So I think c is equal to 1. That's a great question. So I did it, well, I do it, I think I'm gonna do it Professor Fodry's way because I like her way better than mine. Pick any other value for x you want. What's your favorite number for x? Somebody say it loudly. 0. Plug in x equals 0 and plug in the stuff that you know. And a and c. Does that make sense what I mean by that? You know a is 3, you know c is 1. Use that information. So I'll have 1 equals 3 times 0 plus 1 squared, which will be 1, plus b times 2 times 1. What is c equal to? 1, and then times 2 because, right? Okay, so that's going to be 1 equals 3 plus 2b plus 2. I'm not getting the same answer that she got. Wait, no, I am. I just can't add. 1 equals 5 plus 2b. 2b is equal to -4, therefore b is -2. Great. And you will get the same answer if you pick whatever, a different x as well. X equals 0 is just easier. You could pick x equals 1, but 0 is a nice number. Okay, so then your original integral, what's it going to become? Becomes integral of 3 over x plus 2, okay, plus 1 over, nope, wrong, -2, I was just testing you guys, passed again, plus -2 over x plus 1, lastly, plus 1 over x plus 1 squared. 2 of those are natural logs and 1 of those is not. Which one does not integrate to a natural log? The last one, right? Okay, so we'll have 3 natural log absolute value x plus 2 minus 2 natural log absolute value x plus 1. That last one, think about it as the antiderivative of x plus 1 to the -2nd power. Right? What's antiderivative of stuff to -2nd power? I think somebody said it. Could you say it a little louder? Yes, -1st power. Also divided by -1.
You forgot the positive no line above.
I forgot the what?
It's plus the integral.
Oh, thanks. So this will be minus x plus 1 to what new power? Negative 1. The hardest thing with these is to run out of space because it just takes so long. So 3 ln absolute value x plus 2 minus 2 natural log absolute value x plus 1 minus 1 over x plus 1 plus c.
Would you correctly write that as 1 over x plus 1 or x plus 1 to the negative first?
I think either one's okay as long as you use parentheses. Does that make sense? So, does everybody understand how to make the partial fraction breakdown if you have a repeated linear factor?
Yeah.
Okay. So the next thing we're going to handle is something called an irreducible quadratic. Okay, but they're going to be easy irreducible quadratics. So irreducible quadratic means it has a power of 2 and doesn't factor. And we'll go no higher than quadratics, so don't ask about it, it's not going to happen. Okay, you're going to have linears and quadratics and that's it. So how does this denominator factor? X times x squared plus 4, yep. Okay. And x squared plus 4 does not factor. No, it is not x plus 2, x minus 2, that's x squared minus 4. So when you have a quadratic factor, the numerator, when you break it down into a partial fraction, above it has to be a linear thing. Kind of like 1 degree less would be a linear thing. So you have an a over x for the x factor. The linear thing above x squared plus 4 is bx plus c. Like it's not just x, it could have been, a linear thing could have been x plus a number. But from there, it's more or less the same procedure. Okay? So first thing is just know the breakdown. Right.
Could you repeat why it's bx plus c?
The only y that you know enough to understand is that it has to be the most general expression for a linear function. As in, like, the real reason why is pretty complicated math.
So basically whenever you have like a quadratic with a linear function above it?
Yes, and whenever you have a linear function, you put a 1 degree less constant above it. So that's kind of the general pattern, but it's just the pattern for what is a linear function does include two things. Okay, so what happens when I multiply by the denominator? I get 2x squared minus x plus 4 equals a times x squared plus 4 plus bx plus c times x. Okay, so is there a clever number you can plug in to make some stuff go away? X equals 0. That gives you 4 equals, I believe, 4a. So that means a is equal to 1. Okay. Now, in the previous problem where we knew 2 values and only had to find 1 more, this one we know 1 value and have to find 2 more. Does that make sense? It's a little bit different. So I'm going to show you the way that your book does this to see if you can also, because that's the best way to do this particular problem. I'm going to distribute the a and distribute the x. And it gives me 2x squared minus x plus 4 equals ax squared plus 4a plus bx squared plus cx. Is that okay? All I did was distribute a and distribute x. Yes? Okay, now I'd like you to group stuff. How many terms have x squared? 2. And they are, so if I write that as a plus b times x squared, do you agree that that's the same thing? And then if I write it as plus cx and plus 4a is all okay? Okay, so I'll write that down and we'll see what we do next. So, yeah, so thing on left equals thing on right, does it not? So does it make sense then that 4a has to equal 4, doesn't it? Yeah, so, but we already know a, but anyway, 4a equaling 4 tells us that a has to equal 1, which is consistent with what we already had, right? Notice that this c is the coefficient of the x. What is the coefficient of the x on the other side? -1. So therefore c has to equal -1. You see the matching coefficients? Like a's and b's are numbers, right? The coefficient of the x part has to equal the coefficient of the x part on that side. For them to be equal, they must be the same.
So B is also
And so what does the, one second, make sure you all get it right. What does the a plus b have to equal? 2. And so since you know a is 1, use that info. 1 plus b must equal 2, and therefore b is 1. Your book does every problem that way, so if you really feel like looking at it, you could. It's just that it's a lot more tedious when you can plug numbers in. I know of no other way to finish this problem but this.
I did that a little bit differently. When I had a equals 1, I substituted that in and subtracted x squared plus 4 from both sides.
I can see that probably will also work. Did you get the same answers?
Yeah.
Then you're fine. Okay? It's probably not luck in that case. Yes?
So if like the quantity x squared plus 4 was squared, then it would be cx or dx plus e.
And over x squared plus 4 squared. Yep, we'll have one of those as well, but that would be the general pattern. Okay, now this is all the algebra. Let's actually do the whole calculus part of it, right? Oh, man. Okay, so that's equal to integral of 1 over x, right? Plus 1x minus 1 over x squared plus 4. Does everybody do that, copy everything down correctly? Okay. Can you do the first one? ln, yep, of absolute value x. Can you do the second one with the plain old u substitution? You cannot. If you let u equal x squared plus 4, what's du? What do you have? X minus 1. So how you have to handle that last one is break it up into 2 fractions, but it's quite easy. So you make it into 1 over x plus x over x squared plus 4 minus 1 over x squared plus 4. Do you agree that that's the same thing? Yeah. Okay, and now you can integrate every single term. So what's the antiderivative of 1 over x? ln absolute value x. This next one, I'm going to be a little bit lazy and not do the u sub. What would you let u equal? X squared plus 4. What are you going to get? So for this, it's going to be ln. There's going to be an x squared plus 4 inside. What has to be outside to sort of compensate? 1/2. If you have to do the u sub to convince yourself, this is what you would do. Okay? And how about the last one? We did one of those. We did those yesterday, right? Arctan, yeah, so it's negative. Does this one have a coefficient? 1 over 2. Arctan of x over 2. Do you see how the middle and the last are just a tad bit different? One has x in the numerator and one does not, right? That changes the result of what function it is quite drastically, yes? And then, I was just going to say it. You don't need absolute values around the x squared plus 4 because x squared plus 4 is always positive. So if you left them off there, it's totally fine. Okay. Everyone okay? All right. So sometimes there are clever applications of substitution that when you do them, they can make it into integration by parts. And this is one of those examples. So letting u equal x plus 1, I don't think it's going to help. You can try it, but I don't think it's going to work. So the thing that you do in this one is you let u equal the root of x plus 1. This one is quite clever. And it's not immediately obvious that that's going to work, but it's just we're going to give it a try and see what happens.
What does this the other problems.
We'll get there, okay? Just give me a second. Just let me, you just gotta do something patient. Let me finish. Jeez. So that's x plus 1 to the 1/2. So what's du in this case? 1/2 x plus 1 to the -1/2 dx. Or it's, if I say 2 root x plus 1 du equals dx, is that okay? Okay, and then what is that? That's the same thing as 2u du equals dx. Do we agree with that? Okay, that's all pretty clever, right? Okay, so the parts of our integral we've replaced, it's become the x plus 1 is u, the dx is 2u du. How about the denominator? What would you replace x by? Great, you had u equals root x plus 1. Square both sides. U squared equals x plus 1. Therefore, x equals? Yep. And if there are problems like this, there's going to be a hint. Does that make sense? So that becomes u squared minus 1. And at this stage, do we see that now we can maybe see what this problem has to do with all the other problems?
Yeah.
Yeah, because now what happens is you get something that's quite similar to what we already had. Okay. So first of all, can we go off in partial fraction, or do we have to do division first? Division first. I shouldn't be allowed to speak. Division. So 2u squared, and you're dividing u squared minus 1 into it. Yes?
Is it a trigonometric substitution for this?
Maybe. I don't know if it'll work. Okay? Like I'm saying, I'm just not sure. It's completely possible that it will work, though. Like, it might, okay? I just don't know. So if I do this, what do you multiply u squared by to make it match 2u squared? 2. So 2u squared minus 2. Take away, what's your remainder? 2. So that's integral of 2 plus quotient over remainder.
I think it's remainder over quotient.
Plus remains remainder over quotient. Yeah, sorry, I said that backwards. Okay. Now what do you have to do next to the 2 over u squared minus 1? Do that thingy, yeah. The thing we're just doing, right? So how does u squared minus 1 factor? U minus 1, u plus 1, or vice versa. So I'm going to do u plus 1 first. The 2 equals a times u minus 1 plus b times u plus 1. So if u equals 1, I think we get 2 equals 2b. So b is 1. Is that right? What else can you plug in for u? U is negative 1. You get 2 equals negative 2a. Therefore, a is negative 1. There we go. And I think now you can differentiate everything, right?
Scary part's gonna be the resubstitution.
Oh, it's not that scary. I think you're just more afraid than you need to be.
think I'm not afraid of a problem. I just imagine the Yoda sitting there saying, "You will be."
Oh, Yoda. Your teacher's like Yoda, old and wise. Ha ha ha. Okay, that didn't get the response I thought it would.
Entirely curious.
You're supposed to say, no, you're not old.
No.
Okay. So, on a question, I mean, you might see questions like that on your homework, but it's a kind of a challenging question to give you without giving you a slight hint as what substitution could be. But the point is, like, letting u be a root of something does often help. We did that in a previous problem too, didn't we? There was a problem that was like sine of square root of u or something like that, or I think on your homework you had like cosine of the cube root of something, the cube root of x or something, on the take-home quiz. If you do a u substitution, it became integration by parts, right? So that trick that we did there kind of applies sometimes here as well. Okay. This next one, we're going to set up. Okay, so first I want to do the whole substitution business. This one's a much more obvious substitution. What do you let u equal? E to the x. And then du is e to the x dx. So that becomes the integral. The denominator is u minus 2. What does the e to the 2x become? U squared. And in that numerator, is e to the x a u, or is it just gone? It's part of du, so it's gone. That was the thing I really wanted to point out here. That the e to the x in the top is part of the du, and so it just becomes a 1. Yes?
Can you write that as du divided by the
Yep.
denominator?
Yep, you can. And I'm just going to give you the partial fraction decomposition and then move on to the next problem because it's kind of similar to a previous one that we did, okay? So when you're breaking down 1 over u minus 2 u squared plus 1, what does it break down into?
A over u minus 2
Uh-huh.
plus b over u.
In this case, it'd be bu plus c over u squared plus 1. Does that make sense? It's the whole, when you've got a quadratic term in the bottom, you need a linear term in the top, right?
There we go.
Yep, exactly. And it does need to be the same variable. From there, it's quite similar to the one we just did. Look at the notes online and you'll see the solution. Okay? I just want to go over how to find the coefficients for the next one, okay? So this is by far the most complicated example. Your denominator contains repeated irreducible quadratic factors. So is that what you guys have? Like grossness, okay? I think the directions say set up, right? As in we're not going to make you solve it, I just want to set up how it's going to work. So we have whole host of messiness. Over x times x squared plus 1 squared. So first of all, do you believe that if you were to expand and multiply, the denominator's degree is bigger than the numerator's?
Yes.
Yes, because you're going to get x squared plus 1 squared ends up with an x to the 4th in there somehow, times the x means x to the 5th. Okay, so we're good to go there. Now, you have an a over x for the linear factor. You have a bx plus c for the quadratic. And then you have another one, dx plus e, sorry, over x squared plus 1 squared. So sorry. It's gross.
I got it, I think the best.
Huh? Oh, your test will be this problem only. Kidding. Okay. So 5x to the 4th plus 7x squared plus x plus 2 will equal, what two things will be multiplied, what will be multiplied by the a when you multiply by the denominator of the left side?
X squared plus 1 squared.
X squared plus 1 quantity squared. Yep. what's multiplied by the bx plus c? X and x squared plus 1. How about the dx plus c? Just x. Whew.
So you didn't have to do long division on this one?
You only have to do long division if the numerator's degree is bigger than the denominator's degree. So it's reversed here. Bigger than or equal to, that is, sorry. Yep. Okay, is there a good number we can plug in?
0?
I think 0 does some stuff, yeah. X equals 0, that tells you 2 is going to equal a. Right? You agree?
0 eliminated everything.
Okay, now we have to do the whole like gather like terms business. Ugh. Okay, so here we go. Ready? So I'm just going to take this expression and expand stuff, okay? So a x to the 4th plus x squared plus 1. You buy that?
Oh, I see, you didn't factor in the A.
Yeah, it's just this is kind of like an aside. Sorry.
X squared,
Say that again?
isn't it X?
Oh my gosh, yes it is. It is. I was just testing again and you passed. It's plus 2x squared. Yes it is. X to the 4th plus 2x squared plus 1. Here we're going to have, I just can't do it too fast or I'll make a mistake, bx plus c times x cubed plus x. And then dx squared plus ex. So ax to the 4th, 2ax squared plus a plus bx to the 4th, cx cubed, I know, grown, bx squared plus cx, dx squared plus ex. We're almost done.
All I have to do is figure out what the coefficients are there, right?
Yeah, so these are the 4th guys, right? So a plus b, x to the 4th. How many cubes do we have? Just 1. Cx cubed. How many squareds?
2a plus b plus b.
2a plus b plus d. So that's this guy, this guy, this guy. How many constants? 2c plus e, right? And I think there's only, so that was linear, sorry. How many constants? Just a.
I think we're out of time.
Yeah, we are.
You were supposed to set it up anyway.
Yeah, which we're almost done, so you can finish it from there. We'll finish it next time.